to work this problem, I have to do what we call partial fraction decomposition. I need to take this fraction and split it up into two fractions that would add to give me this fraction right here. So this one is a very basic problem, and what I would do, here's the algebra part of this calculus problem. So I'll take 5x minus 19 over x minus 7 times x plus 1, and I'll say, well, this is going to equal something over x minus 7. So I'll say a over x minus 7 plus something over x plus 1. So I'll say b over x plus 1. And the way to proceed, or one of the ways to proceed, would be really to do what I did yesterday, showing you that how to add two fractions where you have to get a common denominator. We're really going to work with this side and say, okay, I'm going to add these two fractions. So just like we did yesterday, this would be a over x minus 7. By the way, what is the LCD? LCD is x minus 7 times x plus 1. I'm working with just the right side right now. So I'm going to take a over x minus 7. I have to multiply that by x plus 1 over x plus 1. And then I'll take plus b over x plus 1. And I have to multiply that by x minus 7 over x minus 7. And you really just proceed like you're adding two fractions. So I'm going to say I have a times x plus 1 over x minus 7 times x plus 1 plus b times x minus 7 over x plus 1 times x minus 7. Now you multiply the numerators. Do not multiply the denominators. When you're first working with this, you might be tempted to do that, but do not multiply denominators. I will get this, ax plus a plus bx minus 7b over x minus 7 times x plus 1. Now my job is to find out what a equals and what b equals. I'm going to, in the numerator, combine like terms. That'll be ax plus bx. They're the like terms, and then plus, and I'll put in parentheses, a minus 7b. That's over x minus 7 times x plus 1. The first set of parentheses in the numerator, I will factor out the x. I'm going to put the factored x out at the back. A plus b times x, and then I'll have plus a minus 7b for the constant term over x minus 7 times x plus 1. Now, the very next step, this is where students sometimes will ask a lot of questions. The very next thing I'm going to say, well, you know what? I know that a plus b equals 5, and I know that a minus 7b equals negative 19. Now, I'm going to write that on the side here. Sort of, this is a little different from, it's the next thing I need to do in the problem. So I'm going to separate it because it has nothing to do with these equal signs right here. But I know this, that a plus b equals 5. And I know that a minus 7b equals negative 19. Now there I have a system of equations. And the biggest question that people ask, the biggest question that students ask is, how did you know that? Raise your hand if you know how I knew that. Not very many hands up. All right, a few more. Okay, this is how I knew that. Look back at the original problem right here. And the coefficient in front of x is going to equal the coefficient in front of x right there. So a plus b equals 5. And this is the constant term, a minus 7b. And that's going to equal this number right there. So I just kind of plucked them off there from the original problem. Now, this gives me a system of equations, and I need to solve this system. You can do substitution, you can do elimination, and maybe there's some other variety of things we could do, but I'm looking at it and I'm thinking, I'm going to subtract the two equations. I'm going to eliminate the a. Or maybe I could multiply the bottom one by -1 and add the two equations. I think I'll do that. So if I take this system and I have a plus b equals 5, and I'm going to multiply the bottom one by -1, negative a plus 7b equals positive 19. And when you add these two, well, you're going to get 0 for the a, 0a. Well, 8b equals 24. And what does b equal? B is 3. And then to find a, I can substitute into either equation. Well, I have a plus b equals 5. So a plus 3 equals 5. And a equals 2. Now I'm ready to go back to the integral problem. I'm going to go back to the original right here. And I'll just take this, and I had the integral of 5x minus 19 over x minus 7 times x plus 1 dx equals the integral. Now a was 2, and it was 2 over x minus 7. So the integral of 2 over x minus 7. b was 3, so plus 3 over x plus 1 dx. This splits into two separate integrals. The integral of 2 over x minus 7 dx plus the integral of 3 over x plus 1 dx, and just do each one. The 2 I could factor out. 2 times the integral of 1 over x minus 7 dx. That 3 I could factor out, plus 3 times the integral of 1 over x plus 1 dx. And now the integration part of these problems is not the hardest part. 2 times the natural log of the absolute value of x minus 7 plus 3 times the natural log of the absolute value of x plus 1 plus c, and there's the answer to that problem.